Hello, everyone, and thank you for joining us. I'm David Robinson. I'm the Director of Membership and Meetings for the Linguistic Society of America, which is sponsoring this webinar. Thank you for taking the time out of your day to join us. I hope you and yours are staying safe and healthy. Let's just wait another minute or two to allow a few more people to log on, and then we'll get going. Thanks again. Okay, I think we're ready to start. Again, my name is David Robinson, Director of Membership and Meetings for the Linguistic Society of America, which is sponsoring this webinar. Thank you for joining us. While I'm talking, you'll be seeing a brief slideshow about the LSA and what we do, and you'll see some information also about a special membership discount for participants in this webinar. We're excited to present this most recent in our series of Meet the Authors webinars from the LSA's flagship journal, Language. We're grateful to our panelists for taking the time to participate and to you for being here. I just want to take a few more moments to let you know how the webinar will work and to make sure you're familiar with the GoToWebinar control panel. If you would like to download copies of the panelists' slides, you'll find those in the handouts section of your dashboard. And if you don't worry if you don't get them during the webinar, we'll have copies available along with the recording in probably by this afternoon. Also, you may have noticed that your microphones are muted. That's so we don't get background noise from all of the attendees. We do encourage you to ask questions at any time, and you can do this using the questions widget on your dashboard. I'll go ahead and pass the questions on to the panelists in the order that they come in, and they'll answer them during the last half hour of the webinar. Our panelists today are Marieke Schouwstra and Simon Kirby. They're both of the University of Edinburgh. They are two of the three co-authors of From the World to Word Order, Deriving Biases in Noun Phrase Order from Statistical Properties of the World, which will appear in Language Volume 96, Number 3. That's the September 2020 issue, and it's available now online at the Project Muse website for the journal through the LSA's Publish Ahead of Print initiative. Their collaborator and lead author, Jennifer Culbertson, also of the University of Edinburgh, is unable to join us today. And without further ado now, I would like to turn the floor over to Simon, who will take it from here.
Okay, thanks very much. And thank you all for coming to this webinar. Jenny passes on her apologies that she's not able to make it today. She was unable to make it at quite short notice. So we're presenting, mostly presenting her slides today. So you can insert excuses on my behalf here already. So we're going to talk to you today about the work that's being presented in this language paper that's coming out next month. But I wanted to start out with a broader question. So this is the question that is behind a lot of our work at the Centre for Language Evolution in Edinburgh, where Marieke, Jenny and I are based. And that's really why are languages the way they are and not some other way. So if we look at language variation cross-linguistically, we find it's constrained in specific ways. So some language types are more common than others. And the question we're really interested in is, what are the origins of these constraints? And specifically, we can break that down into sort of two subsets of questions. One, how specific are the origins of these constraints to language? Are they domain specific or rather more domain general? And to what extent are these constraints learned or derived from innate properties of the biology of our species? So if we think about what the possible sources of constraints on linguistic variation, they could come directly from the linguistic system itself. So in that way, they would be very domain specific. Or perhaps these constraints derive from more general properties of the cognitive system that supports language. So these may be less specific to the linguistic system, more general cognitive biases. Or possibly that these constraints on variation don't derive from individual cognition, but rather are accidents or side effects of the history of languages. So all of these are possible, and it's likely that that the ultimate question to why languages are the way they are is going to lean on all three of these in varying proportions. So what we did in this paper was raise these kinds of questions in a specific sort of subdomain of language as a kind of test ground for posing and answering these questions. And this subdomain was noun phrase, and specifically word order within the noun phrase. So if we look at a complex noun phrase in English, like this one, those two purple chairs, we can see that it's made up of the noun at the end of the noun phrase, and then this stack of pre-nominal modifiers, the demonstrative, the numeral, and the adjective. And the key thing here is that this is the order they come in. So demonstratives come before numerals, which come before adjectives, and then the whole lot is before the noun. But that's not the same, obviously, in all languages. So, for example, if we look at Thai, we have the reverse order. So we have post-nominal modifiers. And you'll notice that the order of the modifiers is the exact mirror image to the English order. And these two aren't the only possibilities. So, for example, in French, we might have a post-nominal adjective here. So demonstrative, numeral, noun, adjective. And there are other options available. So Indonesian, numeral, noun, adjective, demonstrative, and Kitaraka, noun, demonstrative, numeral, adjective, which is the same as the English order, but with the noun at the start of the noun phrase rather than the end. Okay, so there's a whole range of possible orderings of these modifiers in the noun phrase. Now, the important thing and kind of starting point for our investigation is that these different orders aren't distributed evenly. So this is data from Dreyer, 2018. So this is just the raw frequency in his data set of languages with these different logically possible orders within the noun phrase. And we can see Thai, the Thai-like pattern is the most frequent, and the English-like pattern is the second most frequent. But the important point here really is that this is skewed. So this is a highly skewed distribution where most of the orders are vanishingly rare, and the bulk of the orders of the world's languages are up in a smaller, constrained set of possibilities. So this is what we mean by constraints on variation. These are statistical properties where some orders are more frequent than others in a way that is clearly not just due to chance. Okay, so this is the kind of thing that we want to try and explain. So how do we go about tackling a question like this? So here's a starting point. If we look at the noun phrase, we can see it as being hierarchically structured. Specifically, we can see the adjective as being closest to the noun in hierarchical structure, and then the numeral, and then the demonstrative in this form. Okay, so that's a proposed hierarchical structure to an underlying structure to the noun phrase. Now, if we, for the moment, assume this structure, it gives rise to an interesting set of properties. There are a subset of the logically possible orderings of the modifiers in the noun phrase that we're going to call homomorphic orders. And they're listed here. There are these 8 orders. Now, these homomorphic orders are special in that they are linearizations of the 3 modifiers and the noun that preserve the hierarchical structure that we're proposing is underlying it. So here, this first one here, demonstrative, numeral, adjective, noun. This is the English order. And here, down here, we have the Thai order, noun, adjective, numeral, demonstrative. And all of these orders have the adjective closest to the noun, and then the numeral further out, and then the demonstrative further out again. So we call this homomorphic because there is a transparent relationship between the linearization of the words and the proposed underlying hierarchical structure. Okay, so why is that interesting? Why is it relevant? Well, if we look again at Dreyer's figure, now I've colored in green the homomorphic orders. And what we see is they're clustered up towards the high frequency end of this graph. So the vast majority of the world's languages structure their noun phrases in a way that is homomorphic. So languages whose linearization is transparently related to this hierarchical structure are vastly more common than ones where their relationship is not homomorphic. Okay, so that's kind of preamble. Now this isn't, as far as I can see it, this isn't an explanation. It's an observation of a possible relationship between hierarchy and typology. What do we need in order to make this a satisfying explanation? Well, we need to answer a couple of questions, and these are the ones we ask in the paper. Firstly, we want to ask, is there a cognitive bias for homomorphic mappings between underlying structure and linear order? In other words, is this proposed special nature of homomorphic orders something that's actually reflected in the way in which real people process or produce language? So is there some cognitive bias that favors homomorphism? That's one question. That's the first question we're going to ask. And secondly, and importantly, even if we buy the idea that homomorphism is a real thing, it's a cognitive bias, we're still leaning on this underlying structure, the hierarchical structure underlying the noun phrase. And so we really, to be a satisfying explanation, we really want to understand the origin of that underlying structure too. So we're also going to answer that question in this talk. So just to give you an outline of what's going to happen next in the talk. So for the first half, we're going to tackle that first question. Is there a bias for homomorphism? I'm going to present some previous experimental evidence, mostly from Jenny's lab, using artificial language learning that supports the idea that there is indeed a bias for homomorphism. And then Marieke is going to present some new experimental evidence that's in the paper from the silent gesture paradigm. And then in the second half of the talk, we're going to look at the origins of this underlying structure that linearizations are homomorphically mapped to. And we're going to argue that it's a conceptual representation reflecting the strength of association between the meanings that are expressed by modifiers and the objects that are expressed by nouns. And we're going to give evidence for that from corpora to argue that this conceptual representation is learnable by children. And then we're going to go back to the silent gesture method, and Marieke is going to show how we can actually use that experimental evidence to further bolster our claim that there is a connection between the strength of association and what participants do in the lab. Okay, so get started. So So I'm going to give you a quick overview of work by Jenny and colleagues, notably David Adger and Alex Martin, using artificial language learning to try and get at this homomorphism bias. And what they did was they created an artificial language where modifiers occurred after the noun. And these were presented to English participants who are obviously used to the reverse order. But they constructed their training data in such a way that participants learned that the modifiers came after the noun, but they were never given evidence about what the relative order of multiple modifiers would be. So this is why we call this ambiguous input. So we're really asking, what do participants do when they have to extrapolate to combinations of modifiers where they really have no evidence in their training data about what to do? What order do participants infer? So just to flesh that out a bit, in the experiment, participants were trained on the order of a noun and a single modifier. So in one condition, they are given nouns and demonstratives and nouns and adjectives, but they're never shown a complex noun phrase with both a demonstrative and an adjective. And then they were tested they were forced to produce phrases with these multiple modifiers. So then they had two options. They could either produce something like this, where there's the noun, then the demonstrative, then the adjective, or they could produce the noun, then the adjective, and the demonstrative. Now, both of these are consistent with their training data. Similarly, in a condition where they were trained on demonstrative and numerals, these were their two options. And finally, another condition where they're trained on numerals and adjectives, these were their two options. Now, both of these options, as I say, were consistent with the training data in that they're post-nominal modifiers. So what do they do? So if they were sensitive to homomorphism, they should produce these bottom orders, where the adjective is closest to the noun compared to the demonstrative, or the numeral is closest to the noun compared to the demonstrative, and so on. If, on the other hand, they were influenced by their native language, which was English, they would choose these options. Now, this isn't English word order, but it's at least got the modifiers in the right order. So these orders are the ones that are closest to English surface order, and the other ones are the ones that are closest to are predicted by homomorphism. Okay, so in the experiment, they were trained on this artificial language. So for example, here's a participant being exposed to the artificial language words, a sentence, noun phrase, sorry, for a red feather, which is expressed feather red. And here they're being trained on feather that, the demonstrative. Okay, so that's the kind of training they got, which is auditory training. And then in testing, they were asked to respond to something like this, where they're asked to express that red feather. So they could produce either of those two orders. Okay, so what did they do? So in this graph, I'm going to show it so that the homomorphic orders are at the top, and the anti-homomorphic English-like orders are at the bottom. So in the demonstrative and adjective condition, they produce homomorphic orders. In the demonstrative and numeral condition, they produce homomorphic orders. And again, in the numeral adjective condition, they produced homomorphic orders. Just one thing I note here, that the strongest effect here looks like the condition with the adjective and the demonstrative. And note that those are the two things that are most far away from each other in the hierarchy. And we might come back to that in the discussion. Okay, just to summarize where we've got to. Participants were more likely to infer that the adjective should be closest to the noun and the demonstrative furthest away, even though their native language would position these two differently in surface order. However, there's a little bit of a worry here that maybe what's going on is that they're transferring from English. For example, they might be just producing a mirror image order from English. So that's one of the problems of doing artificial language learning experiments is you always are going to have participants who have a language, and there can be, there's likely to be some transfer from their native language in an artificial language learning experiment. So one of the things we thought we would ideally have is a methodology where this transfer is minimized. And that's what I'm going to hand over to Marieke, and she's going to talk about just such a methodology.
So the methodology we used to elicit utterances where we minimize transfer from the native language is called silent gesture. And this is a paradigm in which lab participants are asked to describe things, to convey information using only their hands, but no speech. And this has been shown to minimize influence from spoken language. For example, in a paper by Susan Golden-Meadow and colleagues in PNAS 2008. And just to give you an idea of what it looked like, I'll show you the results from this paper. So what Susan Golden-Meadow and her colleagues asked from participants, these participants were from four different groups of speakers from different languages with different dominant orders. And they were asked to describe simple transitive events. And in this case, first they asked participants to describe each event just using spoken language, and they paid attention to the ordering of subject, object, and verb. So we're now going out of the noun phrase domain and just looking at basic word order for the moment. And what you see in the graph is that people from these different languages produce different orders, and that's very obviously the case because these languages have different dominant orders. So they simply followed the order of their language when they used speech. After speech, they asked participants to describe the same events, but now using only gesture and no speech at all. So what these participants do is they convey information in a way that they haven't really done before, and they basically they have to improvise. They have to improvise a way to get across what they see in a way that they're not familiar with. So this is in a way building linguistic structure from scratch. And so instead of so that the experiment that Simon described earlier has people learning things and then extrapolating on the basis of what they learn. But here, basically, you can say we give participants no input, and we ask them to convey information and then see what happens, see what they do. And it turns out what they do when they describe transitive events, well, I'll talk you through the two examples displayed here. So the top example is a girl covering a box, and this is conveyed by first doing some kind of hair gesture to refer to the girl, and then a box shape, and then the covering. So it's girl, box, cover. And the other example is a captain swinging a pail, and again, first the captain is introduced, and then the pail is described by using some kind of hand shape, and then the swinging. And so we see here that participants use SOV word order to describe those events. Now, quite strikingly, excuse me, there is quite a difference here between the speech and the gesture outputs, where participants, despite the differences in the dominant order of their native languages, they all use the same gesture order when they describe those transitive events. So subject, object, verb seems to be the most intuitive way to to convey this type of information. And in a more recent experiment, we dug into this a little bit further. So this order has been suggested, an order that comes from conceptual structure. So in the Golden Meadow paper, it was proposed that to convey information about an event, what people prefer when there's no conventional language that they can use, what people prefer is to present the specific information before the more relational information. So this has to do with the conceptual structure of the event. And in an experiment that looks at different kinds of events, we dug into this to see what is going on with this conceptual structure. I'll show you this example. So here is an event that is very much like the events that were used by Golden Meadow and colleagues, a nun throwing a violin. You see the participant is first conveying the nun, and then she mistakes the violin for a guitar. But in the end, it doesn't really matter. You know what she means, and we can also easily read off the word order from this. So this participant is using SOV word order. Now, when we compare this kind of event with a different event, so this is a cowboy looking for a jug. In this event, the patient, so the jug, is not specific. So the jug can be, it's not about the object itself in this case, but it's really more about the meaning of the patient in this event. It could even be that the jug doesn't exist. Someone can be searching for something that is not actually there. So here the conceptual relations are different, and it turns out that this is expressed in the gesture order when participants describe this using silent gesture. So what we see the participant doing here is convey cowboy, and then search, and then jug. So the jug comes last in this case, and the order becomes SVO. And in our experiments, participants happily go back and forth between SOV and SVO word order, depending on the conceptual properties of the meaning that they convey. So here we really see how gesture order in an improvised gesture task is sensitive to the conceptual structure of the information they talk about. Okay, that brings us back to noun phrases. We were interested in whether participants, whether we could see evidence for a homomorphism bias when participants describe complex noun phrases using silent gesture. So again, given no input, what do participants use? What orders do they like? And to elicit descriptions of complex noun phrases, we had participants sit at the table and present pictures on one of two iPads that were placed in front of them. So there would always be one iPad closer to the participant and the other one a bit further away. And on the iPad, on one of the two iPads, we would present a picture and then ask them to describe what they see using only gesture and no speech. Now, the pictures that we used in this task were simple pictures of shapes with shapes that were either stripy or spotty, and there would be either 4 or 5 of the shapes, and they would, like I said, they would be presented either on the near or the far iPad. And so the main question is, will participants produce homomorphic orders? Let's look at an example of what participants did. So here on the right-hand side, you see the the meaning that is represented here can be translated as these 4 spotty squares. So the squares are presented on the iPad nearest to the participant. And what the participants do produce is these 4 squares spotty. So that is demonstrative, numeral, noun, adjective. Okay, so note that this is not the order of English. We have another example. Here you see on the right-hand side, you see those 4 stripy triangles. And what the participant produces in this case is those triangles, a stripy 4. So we'll look. So the participant is indicating the top iPad and then doing triangle, stripy 4. So that is demonstrative, noun, adjective, numeral. Again, not the order of English. So those were just 2 examples, but now let's look at some aggregated results. And when we focus on what participants prefer in terms of the relative ordering of the noun and the modifier, we see something interesting. So for adjectives on the left-hand side, there's a strong preference. Actually, without exception, these are produced post-nominally. So not following the English order. When it comes to numerals, this is really a bit more mixed. So it's about 50-50. Some people prefer post-nominal and some people prefer pre-nominal numerals. And then for demonstrative, most people prefer to produce these before the noun. And let's now focus on the orders that we observed in this experiment. And so this is a graph very much like the language graphs that we've shown before, just to show you which orders were produced most often by the participants. And this is showing all the orders that were produced in the experiment. What we see on the left-hand side are the 2 most frequent orders, and they were the orders that I showed videos of. So demonstrative, numeral, noun, adjective, and demonstrative, noun, adjective, numeral. Now let's look at the color of the labels. The green labels are all homomorphic orders, so they all have a transparent mapping between that conceptual order we talked about and the linear structure of the utterance. So they all have adjectives closest to the noun, and then numerals, and then demonstratives. The red orders are orders where this homomorphism is violated, and the gray orders are orders where it's ambiguous. So either because there are multiple nouns or because holistic gestures were used, so we couldn't determine what the order was. And as you see, overwhelmingly, homomorphic orders were being produced. And now I can go to the next slide. We're doing this by telepathy, so that's really hard. So this graph displays for each participant the order that was preferred. So basically that was the order that was produced most often for each participant. And so we see that now we're dealing with far fewer orders, but most interestingly, all the orders displayed here are homomorphic orders. So in the previous graph, we did see some red labels, some non-homomorphic orders, but if you focus on what participants actually prefer, it's really clear that there's a very, very strong homomorphism bias. So just an interim summary. In this task, we asked native speakers of English to convey information about about complex noun phrases, and they show a very strong homomorphism bias, despite not following the order of their native language. So they don't produce just English orders. Actually, we don't see any English orders at all in this experiment. So participants do prefer homomorphic orders, similarly to what they show when they take part in a learning experiment. So there they infer homomorphic orders, and here they produce them spontaneously by improvising.
Okay, so at this point we've established that the homomorphism bias shows up in participant behavior. But I want to reiterate that this isn't enough to explain the patterns that we see in the world's languages, right? Because we need the homomorphism bias to operate upon a conceptual structure that, or a hierarchical structure of some kind that looks like the one here, right? So it's all very well having shown the homomorphic bias, but we also want to show where the thing that linear orders are homomorphic to comes from. So that's what the next step of our paper was to do, is try and find out where this underlying hierarchical structure comes from. Is it domain specific? Is it syntactic? Or is it conceptual structure? And is it innate? Is it something we just have to postulate about the biology of humans or the language faculty? Or could this hierarchical structure actually be learnable? Could it be learned from something external to language? So we had this intuition at this point in the project, after we'd done the silent gesture experiments, that this hierarchical structure is a conceptual structure. I mean, that's what we are used to seeing in these silent gesture experiments, that participants' behavior reflects conceptual structure. And moreover, that this could be learned from properties of the world. And I'll try and give you a flavor of where our intuition about that came from. If you think about objects in the world, so objects can have properties, they can have numerosity, and they can be located with respect to an ongoing discourse. And so those three semantic features, if you like, correspond to the modifiers that we see in language: adjectives, numerals, and demonstratives. But these three things aren't equal out there in the world. So our idea was that if you think about properties of objects, they are properties are more tightly constrained with respect to objects than, say, numerosities are. So to give you a sort of intuition, if you think about fruit, fruit have typical colors, like apples are typically red or green, and bananas are typically yellow. Wine is either red or white. So if you just think about color, the range of possible colors that an object can have is limited by the nature of that object. And it's the same for other properties. So stones are hard and bricks are heavy and red, and so on. So that the properties that an object has relate very strongly to the nature of that object. And you can think about this for like textures, like the spotty dog and a stripy zebra. So these things, the range of possible variation in properties is relatively limited once you know what the object is. So there's a strong association between these two things. This is much less true of numerals intuitively. So although we can think of some things, some objects that have typical numerosity, so shoes usually come in pairs, we might have two parents. Keys are usually, a bunch of keys is a rather small number of keys, where a number of grains of sand are likely to be very large. But you have to really reach for these examples. Most objects can come in any numerosity and you wouldn't be too surprised. And then if you think about the status of an object with respect to a discourse, that seems to be almost completely unconstrained. You wouldn't be surprised with any object to say this object versus that object. So there's this, intuitively, there is this difference along this hierarchy of strength of association. And so we wondered, if that's true, if that's a property of the world, then that's something that children could learn. So children, just by observing the world, could learn that there are differences in these associations that may form the core of the conceptual structure, which is then used to create, to map onto syntactic structure with this homomorphism bias, leading to particular linearizations. Okay, so that's really hand wavy and just armchair theorizing. So what we wanted to do was to try and figure out how to measure it. I'll just quickly go over that hypothesis a bit more clearly. So the hypothesis is that the underlying structure of the noun phrase is based on conceptual structure, which encodes strength of association, with properties being more strongly associated with objects than numerosities, and numerosities being more strongly associated with objects than their location or discourse status, and that this is learnable. So how do we test this? How do we evaluate this hypothesis? Well, ideally what we would have is some kind of information theoretic measure of this strength of association between properties and objects and numerosities and objects and so on. And we'd want that to be evaluated against the actual world. So we couldn't figure out exactly how to do that. So we decided to use a corpus of language as a proxy for the world. So the idea is that in a corpus, you are more likely to talk about, or you will talk about things in the world. So the corpus should end up reflecting the statistical properties of the world. So we can use the corpus as a way of testing whether we're right that the properties are more closely associated with objects than numerosities are, and so on. So it's really important just to reiterate this, that this is not, we're not saying that the corpus of speech is what children use to derive conceptual structure, but rather that here we're just using the corpus as a proxy for the world. So kids are going to do this from the world, not from language. So how do we do that? How do we measure this? So we're using as our measure of strength of association, point-wise mutual information. This is a very simple way of measuring how much more likely two things are to appear together than you would expect by chance. So here we have this probability up at the top, which is just frequency, based on the frequency of co-occurrence of two things. And at the bottom, the frequency of the individual things. And this gives you the probability of these things being together if they were independent. So if something is occurring, if the frequency of a pair is higher than expected, given the individual frequencies of the words alone, then the PMI value, the point-wise mutual information, will be higher. If the point-wise mutual information is low, then these two things are occurring, are not occurring with a frequency higher than expected by chance together. Okay. So how do we evaluate this in the corpus? So what we do is we first picked all of the noun modifier pairs in the corpus and their frequencies. We discarded very low frequency pairs. And for the remaining pairs, each pair of noun and particular noun and particular modifier, we calculated the point-wise mutual information for that pair. Then we aggregated them by modifier type. So we, for example, for all of the adjectives, we would calculate the average point-wise mutual information for all of the noun adjective pairs that exist in the corpus. And this would give us a measure of how strongly associated in general are adjectives and nouns, or numerals and nouns, or demonstratives and nouns. So here are the results, and this is using the universal dependency tree bank. And the reason to use that is that we can ensure that the noun, let's say a particular noun and a particular adjective, they are actually related. The adjective is actually modifying that noun. And what we see here is that the average pointwise mutual information for adjectives is bigger than nouns, which is bigger than demonstratives. And this is in line with our hypothesis, right? So that this is saying that adjectives typically occur more often with their nouns than you would expect by chance. And numerals less so, and demonstratives hardly at all. So here's an example. These would be high PMI pairs, alcoholic beverage. So that's saying that beverages are often alcoholic. Dense vegetation, vegetation is often dense. And founders often come with numerosity 7. So those are high PMI values. Low PMI, something like that child. So children can be this or that. Doesn't make much difference. New fact. So facts aren't typically new necessarily. One program, there's nothing particular about program that leads them more likely to be described with the word one. Okay. So this was a very nice result for us. It showed that this idea of strength of association is indeed borne out in the tree bank, but maybe this is just a property of English. So we went and checked it with a lot of different languages. So we have English, we have child-directed speech, and then a whole range of other languages from around the world. And in all of these, we see the same pattern of strongly associated adjectives, less strongly associated numerals, and very, very weakly associated demonstratives. So just to summarize where we've got to, the strength of association differs among modifiers. Objects and properties are more tightly related to each other than objects and numerosities. Objects and numerosities are more tightly related to each other than objects and discourse status. So our idea is that these are properties not of language, but of the world itself, and the corpus is allowing us a proxy for that world. So children observe objects in the world, probably not always glasses of wine, but they'll observe objects in the world that have particular properties and see that those properties are strongly associated with those objects. They might see objects coming in all sorts of different numerosities and so on. And using those statistical observations of the world, they're able to build a representation of conceptual structure that has this hierarchical nature that we talked about. And then this hierarchical conceptual structure that has been learned is mapped onto syntactic structure to form this hierarchy that we've seen before. Now, crucially, we should point out that what we're saying here is that it isn't that we go straight from the strength of association to language. This is mediated by syntactic categories like adjective, numeral, demonstrative. And we know this because the hierarchy is not constructed on a phrase by phrase or modifier by modifier basis. It's not that you reorder your noun phrase depending on the specific words in the noun phrase. Rather, you have grammaticalized that into these crisp categories and positions for adjectives, positions for numerals, and so on. However, it's still interesting to look and say, well, within one of these categories, like adjectives say, are there differences in strengths of association that we could look at? And indeed, people have looked at different subclasses of adjective. So adjectives that refer to color or size or value. So if we look at in English again, big purple chairs is an acceptable sentence of English or noun phrase of English, but purple big chairs sounds wrong. So here it looks like color is more closely associated with the noun than size is. And again, if we look in our corpus, that's indeed what we get. So we have higher PMI for color than for size. So again, just to reiterate, objects come in highly typical colors, but slightly less typical sizes. Okay, so this led to a sort of secondary question for us, which is, could we see this effect, the effect of different adjective PMI values on the order in our gesture experiment? More specifically, if an adjective has a lower PMI then will it, for example, permit or kind of license these violations of homomorphism? So might orders like noun, numeral, adjective, which violates this homomorphic bias, will they be more likely when the specific adjective has a PMI which is more similar to the numeral range? And so Marieke is going to tell you about our follow-up experiment that tested this question directly.
Yeah, so in this, we use silent gesture in this case to measure something quite subtle, because we're really looking within adjectives and looking at different kinds of adjectives. To do this, to compare different kinds of adjectives, we designed an experiment that had two conditions. One of them is a texture condition. As you see on the slide, the pictures on the left-hand side are stripy objects, and on the right-hand side are spotty objects. So ideally, we would have used color, because we saw that color is a very good example of an adjective that behaves really closely to the noun, is closely associated to the noun. But to get participants in an improvised gesture experiment to convey colors, I think is impossible. So we had to go to something else. And actually, we've already shown with our previous experiment that texture works quite well. People have an easy time coming up with spontaneous gestures to convey different textures. And the other condition is a size condition. So here we simply presented the same objects as in the other condition, but this time they were either small or big. So for our stimuli, we used a set that had different objects, so either toothbrushes or pencils, with different properties, so stripy or spotty, that came in different numbers, so either 4 or 5. The ones with 5 are not displayed here because they didn't fit on the slide. And again, they were presented on one of 2 iPads to convey the relative position with respect to the producer of the utterances. So we're interested now to see what people do for the different types of adjectives. Let's start with a texture condition example. So here on the right, you see the meaning that they convey is those 2 stripy toothbrushes. Oh, and I meant to say, we changed our object from squares and triangles to toothbrushes and pencils. The reason for that was to prevent participants from making holistic gestures. Imagine being in the size condition, where you could potentially just convey information about big squares by just making one holistic gesture that conveys both types of information at the same time. We want to avoid that, because that doesn't allow us to derive an order, a surface order. So we know from research on this that for these type of objects that have a particular kind of handling associated with them, that gesturers are likely to use that type of handling to refer to the object. So that's perfect for us. We did indeed have one holistic example where someone depicted an enormous toothbrush and started brushing their teeth with it. That was luckily the only occurrence of a holistic depiction. Good. Let's have a look at this example. So the meaning is those 4 stripy toothbrushes, and what the participant here conveys, let's have a look, is those toothbrushes, stripy, 4. So demonstrative, noun, adjective, numeral. Here's another example from the texture condition. This participant is describing these 4 spotty pencils. And what he does here is pencils, spotty, 4, and then these. So that's a noun, adjective, numeral, demonstrative. These are both homomorphic. Let's look at this one. This is from the size condition. And the meaning here is those 5 small toothbrushes. And let's look at what happens. Those toothbrushes, 5 small. So in this case, a participant has the numeral closer to the noun than the adjective. So this is demonstrative, noun, numeral, adjective. And this is a violation of homomorphism. Now let's look at what participants produce altogether. The top 2 graphs are for the texture condition and the bottom graphs are for the size condition. And if you just focus on the colors of the labels, you can see that there were more violations of homomorphism in the size condition. So there are simply more examples where participants, and in most cases it is a violation by swapping the positions of numeral and adjective. So they basically put the numeral closer to the adjective. This, however, when we did stats on this, comparing the 2 conditions, it didn't come out significant, and it only came out significant when we involved the first experiment, which also had texture information. So this shows that actually people do violate homomorphism, but overall they just prefer homomorphic structures. So just to summarize, the results, so manipulating the PMI of adjectives, so manipulating the adjectives to represent different PMI values in an experiment does change the strength of the bias, in this case of the improvised gesturers, in the sense that they do produce more violations when they are presented with adjectives for size than for adjectives of texture. However, overall, the bias for homomorphism is strong, and that leads to the fact that lower PMI adjectives, like adjectives for size, are still very likely to be gestured closer to the noun than, for example, the numeral. Okay, let's wrap up now and zoom out a bit. So what we propose in this paper is 2 things. First of all, we propose that there is this thing like an underlying structure, and this is a conceptual asymmetry that is learnable by observing the world. And evidence for this, we present the corpus study. The second thing we propose is the idea of there being a preference for homomorphic mappings. And as evidence for this, we present the silent gesture experiment, where very clearly people produce homomorphic utterances. And together, these 2 basically get us to the graph there at the bottom. They explain why noun phrases in the languages of the world pattern the way they do. So that was the question we started with, and these 2 findings give us a nice explanation. Together gives us a nice explanation. And now let's come back to the big picture that we presented earlier, and see how the different parts link up to each other. So again, when a child comes into the world, it will observe objects and their properties and their numerosities and their locations. And from this statistical information, the child will build a representation of the conceptual structure. And this will have that hierarchical information in it. And that conceptual structure is then mapped onto syntactic structure. And that syntactic structure, together with a bias for homomorphism, gets us the linear orders that are common in the languages of the world. Now, what of these elements, what is learned is quite a lot, actually. So the last three parts are all learned. That's what we propose. And if you look at what is domain specific, then the last two elements are domain specific. So the conceptual structure is not domain specific, but the syntactic structure and also the linear orders that are particular for languages are domain specific information. But I need to point out here that the homomorphism bias here is displayed as part of domain specific information, but the bias itself is not. So it's only combined with the structure, but the bias for homomorphism itself is a good example of a very domain general cognitive bias that has a particular domain specific effect, and that's it.
Thank you.
All right, thank you very much, Marieke and Simon. We've come to the part of the webinar now where the panelists will take questions from the attendees. So if you haven't already, you can ask questions using the questions widget. I will pass those on to the panelists, and we've already got a few questions, so I will get to those. Okay. All right, first question here. What characterizes plausibility in language? Can we alter plausibility using word order in NP?
Plausibility. I mean, it depends a bit what we mean by plausible. I guess I'm not quite sure how to take that question. You could I mean, I suppose you might. I'm not sure what the question is getting at, but potentially you could argue that reordering the noun phrase might actually convey something about the conceptual closeness. I'm not sure. Marieke, any ideas?
Yeah, I'm guessing now, but maybe. So there are people who think that there are orders that are possible and that there are other orders which are not possible in languages. And so I don't know if this was meant by this question, but I just wanted to point out that we don't endorse that view. So we don't think that there are orders simply entirely impossible. So I think there are strong cognitive biases that lead to some orders being more likely to be favored than others. But still, these biases can be overruled in all kinds of ways. So languages that that violate these biases are possible, in our view.
Okay, here's the next question. To what degree do you think word order bias transfer is reduced by switching to nonverbal signs? Not sure if you managed to avoid English speakers or only use speakers of languages that do not have to order.
So Marieke, do you want to take that?
Yeah, I'm not sure I heard the entire question, but so just to point out that in our first experiment, there was actually not a single utterance following English word order. So that's pretty strong evidence.
I mean, a gesture sequence. Yeah.
So yeah. So there were no gesture sequences that followed English order. So they they all deviated from the order, the service order of English. So I think that's pretty strong evidence that participants readily abandon their native language order.
So can I add something? So there is a possibility. So what I think we get from the silent gesture experiments is a surprising lack of transfer of surface order. I mean, I think that Susan showed that in her original study, and we've shown it here as well. But there's another possible objection, which may be the question I was getting at, which is maybe participants aren't transferring their surface order, but they may be transferring the homomorphism bias itself, right? So it could be that they're speaking a language that's homomorphic. So when they do gesture, they are homomorphic. So weirdly, they don't choose the surface order, but they're homomorphic. So we're not discovering anything new about homomorphism by using silent gesture. I actually think that's quite implausible, but it's a possibility. So what Jenny and Alex and David Hadger are doing currently is rerunning their artificial language learning experiments with a language that that violates homomorphism. So that's the Kitaraka language. So that's a language which isn't homomorphic, and they want to show that nevertheless participants, given this exactly the same artificial language learning experiment, nevertheless show a homomorphism bias. But Jenny's not here, so you don't get to hear any more about that.
Okay. Thank you. Here's another question. Adjectives are post-nominal in the gesture task. How do we know they aren't relative clauses?
It's a great
that's
question.
A good question. Yeah, we don't know.
We both want to answer this. You ever go first, Marieke?
Yeah, I just wanted to say that we don't know. Of course, we don't really know what's going on there. So we are using the terminology that comes with the noun phrases. But what participants actually do, we don't know, of course, and they might just as well be in their heads using simple phrases that that correspond with the pieces of information instead of just using words. So you could object there that what we are looking at is not actually noun phrases, which I think is a fair objection. But on the other hand, what we're looking at in our experiment is how participants convey complex information, and they're using a method they haven't really used before. And what we simply look at is the order in which they convey the different pieces of information, and whether or not these are genuine parts of the noun phrase maybe doesn't matter so much.
Yeah, I think I would. So there's kind of two ways you could take this objection. So the first is that, well, you're calling these adjectives numerals, demonstratives, but you're just calling them that, so who cares, right? And I think I agree with Marieke in a way. What's going on here? It's about linearization. It's about linearizing a structure that's non-linear. That's so the conceptual structure, the meaning, doesn't have that linearization. So participants are having to make a choice about how they linearize it. And if they do that homomorphically, in a way, it doesn't really matter. I mean, these aren't languages, right? These silent gesture productions are not language. So we are using linguistic categories as a shorthand. There is no sense in which these are nouns or adjectives, right? They're not yet part of a systematic system. In fact, we have other experiments where we think we are catching onto that moment where you go from spontaneous improvised productions and turn them into a system. So, but it's linearization of information that is non-linear. And if there's a homomorphism bias, it should operate there irrespective of what you call these things. So I think that deals with that objection at that level. But there's another level you could take that objection, which is a bit like the previous one, which is you could say, well, hang on, okay, but I'm saying then relative clauses, and therefore they are reproducing English order. And again, I would just say look at the variety. If they were doing a if they were doing a sort of transliteration of English order in silent gesture experiments, we would have seen it in lots and lots of silent gesture experiments. And there's just a diversity of orders that they produce. In other experiments where the native language of the participants has been varied, it doesn't reflect their native language order. So I think the idea that what's happening in silent gesture is some kind of transliteration of an English sentence into silent gesture just doesn't seem very plausible to me. It probably was what I thought when I first started looking at silent gesture experiments, but now I'm pretty convinced that's not what's going on.
Right here. Now we have a couple of related questions, and so I'll just read them both. The first one is, have you considered what contributions communicative interaction could make in the emergence of homomorphism? That is to say, apart from cognitive biases, could biases in the communicative channel itself also shape languages over historical time toward homomorphism? And the second question is, where does the homomorphism bias actually come from? In the end, your experiments and corpus studies don't really address why people prefer to map sentences onto conceptual structure in a homomorphic way.
Superb questions. Marieke, do you want to have a go at the first one?
Yeah, do you want to answer the second one first and then?
Okay. Yes. So the question is absolutely right. We have not in this talk told you why the homomorphism bias exists. We've shown we revealed that we can see it in participant behaviors, and we've used that as part of our explanation of why particular linear orders occur. So where does it come from? So right at the end there, we said we thought that it wasn't specific to language. And I think we can probably go further and say, at the moment, I think the three of us probably also think it's innate. So it's a domain general bias that has domain specific effects when it meets up with linguistic representations. And I think this in general, this is a big part of the story of language that maybe hasn't been told in enough detail, which is that a lot of what's going on in language is probably domain general biases having domain specific effects. So why do we think this? Why do we think that homomorphism is a domain general bias? And here, what I would do is appeal to an even more general bias, probably the most general bias in cognition, which is a simplicity bias. So we see this across all of cognition, across all species. It seems to me that if you have any kind of nervous system interacting with the world, at some level you can find a simplicity bias. That is that cognitive systems expect the world to be regular. They expect the world to be explainable in simple terms instead of more complex terms. I mean, this is really fundamental to how prediction works. For example, you predict that the future will be somewhat like the past. And this simplicity bias shows up in all sorts of different places. And if you think about homomorphism, you can recast that in terms of simplicity. So the mapping between two different structures, a homomorphic mapping, one that preserves information from one structure and the other, is simpler than one that changes that relationship. So homomorphism is simply is what happens when the simplicity bias meets mappings. And you can actually see things like it in the nervous system. So the way in which the nervous system maps the body, for example, is homomorphic. So you have parts of the body that are close in the real world are mapped to parts of the cortex that are close together. And again, this is just a reasonable way of doing things. It arises from a preference for simplicity. So that's why we think it's domain general. But crucially, and I think this is a really important thing I'd like to get across, is that you can have an argument that's based on a domain general bias, and in this case, something that you plausibly call innate, right? We were just born with it. But then it meets a task, and then it has highly domain-specific effects, things that look linguistic. But that doesn't mean that we should be putting something like conceptual structure or these hierarchical structures into our model of the language faculty. It's just that these domain general things, when they meet particular tasks, they can have these highly specific linguistic effects. Now, if after all of that, me rambling for ages, Marieke can remember the first question, I'll be really impressed.
Yeah, I think so. You've actually set me up quite nicely to continue, because now, so Simon has explained why we think that this homomorphism bias is domain general and probably innate. And the question was about this homomorphism bias potentially being a result of pressures from communication. Now, so to take that question, we would probably say no, it's not. So homomorphism is not the result of communicative pressures, and instead we think it's a cognitive bias that was already there, that people come to the stage with even before they start communicating. But I think so. In that sense, we propose that there are biases that play a role before communication takes place, and that play a role in how we reason about the world. But we like to think of the process of the emergence of linguistic rules as something that goes through various stages. And so we propose that homomorphism plays a role quite early on, because that's just because it's such a domain general bias. And that's why we think it pops up already when participants in our lab are improvising to convey information without there being any communicative back and forth. We have actually done these kind of experiments where we do combine the silent gesture method with communicative interaction, which allows us to tease apart the pressures that play a role when there's only improvisation versus pressures that play a role when improvisation is followed up by a continuous back and forth and negotiating of a communicative system. And we've shown that different pressures do play a role there, where participants are heavily influenced by the conceptual structure initially when they produce utterances, and they might go back and forth between different constituent orderings. But once they start communicating, they might want to be more regular in order to make communication easier. So we do recognize that there are that communication affects the shape of language, the structures we see in language, but not necessarily with respect to this homomorphism.
Okay, here's our next question. Would you endorse the view that it takes a longer time for children to acquire nominal word orders that violate homomorphism? One thing I noticed on slide 36 is the lack of survey data on Bantu languages, which display word orders that often go against homomorphism, e.g. noun, demonstrative, number, adjective. Would languages like these be harder for children to acquire in your view?
So I'll deal with the easy part of the question first. So the cross-linguistic survey, one of the things I think it's really important to point out is that the vast majority of the data that was used, that's in the corpus, is neither, shows no evidence for or against homomorphism, because the vast majority of noun phrases in the corpus are not complex noun phrases. So there's actually relatively few examples that have multiple modifiers in them. I mean, this is the kind of thing we worried about a lot when we were doing this, was whether there was somehow that the corpus was building in the thing that we were searching for. And we were really pretty convinced that it doesn't, because there's just not the data there to see the homomorphism or not. So if we were to have a universal dependency corpus of Bantu languages that violated homomorphism, I would hope that we wouldn't even be able to tell by looking at the corpus necessarily, and that it wouldn't have an effect on those results. Now, going to the question about whether a language that violates homomorphism might be easier or not to learn, I mean, I don't know. It's an interesting question. So from the point of view of the kind of silent gesture method we used, that this homomorphism bias showed up in improvisation. And what, as Marieke just was saying, what we found in some of those silent gesture experiments is that these kind of biases that to reflect conceptual structure can be quite easily overwritten. So participants can start off with an order that reflects conceptual structure, but if they're exposed to a different order, they just switch. It's no big deal. Similarly, the artificial language learning experiments, the participants are explicitly not exposed to the complex noun phrases, so they're spontaneously extrapolating to these unseen pairs of modifiers. So we can't tell from either of those whether, in fact, if we presented a full homomorphic violating artificial language and a full non-homomorphic violating language, it wouldn't massively surprise me if there was no difference, that in fact any evidence at all could overwrite it. So that leaves open an interesting question of like, how does that homomorphism bias get into language? You know, if these languages that violate it exist, they're fine, people can learn them, then why do we see this pattern cross-linguistically? And one of the things that we've done in using models and various experiments in different domains at the Centre for Language Evolution in Edinburgh is really tackle this question of whether you can expect a really tiny bias, a very small cognitive bias, to nevertheless have big effects at the population level. And it turns out in lots of situations you can have something that's a bias that's so small that you can't necessarily see it very easily in terms of the learnability or not, or the time taken to learn. But the process of cultural evolution can amplify that small bias up into a big effect at the population level. So there's a bunch of models that show that that's the case. So if you see a big skewing in the world's languages, that doesn't necessarily mean that that's going to be reflected by a huge learnability difference, for example.
Okay, next question here. Hi, the paradigms you use look similar to one of Kenny Smith's studies. I know you were in the same department at Edinburgh, so I just wonder if this study is related to Kenny Smith's or part of a bigger project series.
I mean, Kenny and Marieke and I have other papers where we have done silent gesture work. Some of the videos that Marieke showed there were part of the projects that Kenny, Marieke and I have been working on. As I understand it, Kenny's not done anything on noun phrase order, and nor this study of looking at pointwise mutual information. as a way of measuring conceptual relatedness. But it's all part of a larger, broader kind of theme of work that we're pursuing at the centre of trying, as I said at the start, really, is trying to understand why language looks the way it does by probing these mechanisms that underpin cultural evolution. So Marieke talked about improvisation. So what do people do when they have to really, take a step into the unknown and produce something that they've never seen before? And then there's interaction. What do people do when they have to be involved in a communicative task, which we haven't looked at in this paper? And then there's iteration. So what happens when language is transmitted from one generation to another through a process of learning? And those three mechanisms are crucial mechanisms that drive the process of cultural evolution. And the view we share with Kenny and everybody else in the lab is that if we want to have a truly explanatory theory of language, what we need to do is understand how properties of cognition, properties of the task that we tasks we use language for, are mapped through these processes of cultural evolution to give us the way language is. So it's a fundamentally evolutionary approach to language, but not necessarily evolution in the purely biological terms. It's just evolution as in the process, that it's the processes that matter. The processes that create language is what we're all investigating.
All right, we've got time for perhaps one or two quick questions. Here's the next one. Is the PMI formula sensitive to lexicon size of the category? For example, there are exponentially more adjective words in English than numerals, than demonstratives. Therefore, is it natural that adjectives can give out a high information value and hence a high aggregated PMI for the category?
I can't tell you how much time Jenny and I spent, in particular, worrying about this question. There were months where she would run into my office and say, no, it's all driven by X, and we'd go and look. I worried about that a lot because these three things do, at least in English, line up with respect to size. It turns out I'm now no longer worried about it. So one of the things to bear in mind is that, remember, we looked also at these small subsets of adjectives. We looked at just the colors and we looked at the size terms, and I can't actually remember how many there are, but there's just a handful. And you get numbers there which are within the range for the full set of adjectives. There's also languages in our set which have really quite different sizes for the number of demonstratives and the number of numerals, and yet the pattern seems to be the same. And actually, when you sit down and think about it, there isn't a particular reason why having a larger set of things in the subset of the language you're looking at should give you a different PMI value on average. So we have tried. We've done a lot of randomizations and taking subsets, and we tried to throw everything we can at this to break it. And at least we wouldn't have submitted it if we weren't happy that wasn't the thing that was driving it. But it was definitely the first thing I thought of. It's like, oh, there's loads of adjectives. There's not many demonstratives, so maybe that's it. But no, I really don't think it does.
Okay, well, we have come to the end of the webinar. I know there were a few questions that didn't get answered, but you can find the participant or the panelists' Twitter handles at the beginning of the slideshow. Many thanks to both of you, Simon and Marieke, for making the time out of your day to be with us. Thank you to all our attendees for taking time out of your days to be with us. And just a reminder that we'll have a recording of this webinar available along with copies of the handout, probably no later than this afternoon. I'll send around a reminder when that happens. Thanks again, everyone, and have a great weekend. Bye-bye
Thank you. Bye. Stay safe.
now.